In this video we're building an sanitizer vending machine system. In our previous video many of you requested a PCB-based project. This project is practical, efficient, and built around a clean, reliable PCB design. In an upcoming video, I'll also show you how to order PCBs, including the website name that provides high-quality PCBs at a professional standard. So friends, to start this project we first take an empty sanitizer bottle. This bottle will be used as the main body of our automatic hand wash system. After that we take a BO motor, and according to the motor size, we carefully mark and cut a section on the side of the sanitizer bottle. As you can see, the cutting is done neatly. Now friends, to build this project, we are using a custom PCB. Honestly speaking, I was really impressed with the PCB quality. The finishing is excellent, the copper layers are clean, and the PCB feels very professional. For this project we'll be using all the required electronic components, and now we begin placing them one by one on the PCB. What I really liked about this PCB is that all the component positions are clearly marked, so you know exactly where each component needs to be placed. This makes assembly very easy, especially for beginners. Once all components are placed correctly, we complete the soldering process carefully using a soldering iron. Clean solder joints are very important for proper circuit performance, so make sure you solder each point neatly. After completing the PCB work, we move back to the mechanical part. We take the BO motor and make a small hole for its shaft alignment. Then, on the upper side of the sanitizer bottle, we create another hole to allow proper movement and fitting. Now, we place the BO motor onto the sanitizer bottle and use instant glue to fix it firmly in place. This ensures that the motor does not move during operation. Similarly, we fix the PCB inside the bottle using instant glue, making sure it is positioned safely and securely. Next, we complete all the wiring connections. The connections are very simple, and you can easily follow them as shown. So friends, now let's quickly complete all the wiring connections. It's important to make all connections neat and secure to ensure the project works perfectly. Once the wiring is done, we place a protective sleeve cover over the exposed wires for safety and insulation. Next, we take a magnetic switch module and carefully connect it to the circuit. This switch will act as a sensor to detect the hand movement. After placing the module, we secure the flip cover using heat so that everything stays firm and properly aligned. Once the magnetic switch is in place, we use a double tape to fix additional components onto the sanitizer bottle. First, we place the battery securely and fix it with double tape to prevent any movement during operation. The positioning is crucial for balance and stability, so make sure it's properly placed. After securely fitting the battery, we place a double tape on top and carefully position the magnetic module above it. Make sure everything is aligned perfectly, and none of the wires shift from their place for smooth and reliable operation. We focus on the Nichrome wire. Earlier, we made a small hole on the upper side of the sanitizer bottle to accommodate this wire. The Nichrome wire is carefully positioned inside the motor assembly and aligned to work seamlessly with the BO motor. This will ensure smooth operation and proper dispensing of sanitizer. Now comes the final assembly. We carefully fit all remaining components inside the bottle, making sure every wire, switch, and module is properly seated. The pathways for the wires are neat, and any extra parts are trimmed to prevent obstruction. Finally, the automatic hand wash system is fully assembled and ready for testing. As you can see, when I bring my hand near the sensor, the system activates automatically, demonstrating smooth and accurate operation. Everything is working perfectly, from the motor to the dispensing mechanism. Friends, this project is a great example of combining practical electronics, PCB-based automation, and mechanical assembly. It's safe, efficient, and can be built at home with basic components. I'd love to know how you like this project, so make sure to leave your comments below. That's it for today's video. We'll meet again in the next one.